That working correctly? Looks like it is.
Yep.
Okay. So hi. I've already been sort of introduced, but I'm Muffy Barkocy. I'm a software engineer at Instacart. I've been with Instacart for about 5.5 years now, and most of that time I've been working with our orders database in various guises. First as a member of our orders team, so recording the orders in the database, then as a member of our infrastructure team dealing with the massive growth of, of our orders database. And now I'm on our what we call care tooling team, which deals with all the support calls we get about orders in one form or another. So yeah, it's been all orders, orders, orders for me. What I'm going to talk about today is not actually all that technical. It's more a mindset or a thought experiment that I did. Um, and since we have a couple people here who have actually worked with us, I particularly welcome any commentary from y'all about what you think about this. Anyway, so here we go. Um, so 2020, you may remember about a year ago, there was like a big event. And it was particularly big for Instacart. So what we do is we do same day grocery delivery. And a year ago, I might have had to explain that to people, but now there's all these commercials and I think, newspaper articles. I think everyone's heard of us, but if you haven't been involved in something like grocery delivery, we were kind of working our way up, but we were like some ridiculously small percentage of the overall grocery market because people weren't buying groceries online. Then the pandemic hit, and suddenly instead of, oh, that's an expensive luxury and maybe I'll try it someday when I'm really rich, now it was like, oh, that's something that could potentially save my life. Let me try that right now. And so we became much more of a necessary service. We hit, I think I've actually heard bigger numbers than this. The numbers that they gave me were 3 years of growth in 30 days, which you can see in this graph here. But I think I've heard since then that it was more like 5 years of growth over 5 weeks. So we hit all our targets, but that wasn't necessarily a good thing. I came back from my last trip anywhere to find that our databases were really exploding due to all of this additional traffic. And I was still on the infrastructure at that team at that time, and so I was helping deal with that. And I mean, I'm sure y'all are familiar that it's one thing, like we've got AWS, right? So if we want to scale our services, we get some more servers from AWS and we've scaled our services. It doesn't really work that way with databases. Like a database has a limited number of things it can process at any given time, limited number of connections. And if you're in that same database, and perhaps limited storage, which is a problem we ran into in the past because AWS has certain storage limits. So you have to actually restructure it. You can't just ask Amazon for more database, right? There's actually a lot of work to be done with respect to that. So what did we actually do? We were already in the process of some horizontal scaling, which is also breaking things out into a specific focus areas. So, orders maybe got its own database, whereas users got its own database and that kind of thing. But with the kind of growth we were experiencing, that wasn't good enough. And the orders database in particular, and you'll see more as I talk as to why, but the data we're collecting on orders was so enormous that we also had to shard that database. And so we split it into multiple identical copies, except it was, by user ID, right? Another way that kind of thing is often handled is by retiring old data. So for things where there's only a certain amount of data which is current, the old data just gets moved into your data warehouse and into some storage on Amazon, and then you just delete those rows out of the database. But with our orders, we couldn't really do that because we maintain an order history. And so that's where this idea that I'm going into came from. Oh, I went one too far. How do I go back? Darn it. Previous, there we go. So that part is what we did do. We scaled horizontally, we sharded, we split things up. We did, get the biggest possible instances with the most possible storage. We looked for bad queries and tried to make them better. We looked for things that we didn't have to be doing, all the usual things. But I was thinking, are we really doing everything that we can? And when I started at Instacart, the company, there was a list of company values, and my personal favorite was have a backbone. And I am so sad because we revamped the company values a few years ago. And my now favorite one is this of course but maybe. And it's a good one, but I think have a backbone is like the best value I've ever heard. So I'm sad we lost that one. So what I'm going to talk about in this is not what we did do to scale during the pandemic, but what we didn't do, but something that I thought about. And it ties into, I've titled this talk, Tidying Up Your Data. So it ties into the work of Marie Kondo, who you probably heard, if nothing else, at least a bunch of jokes about whether or not it sparks joy in terms of tidying up in your life. But I think that if you read her book, it really has ideas about how to think about it, and I think those ideas can translate to looking at your data. So yeah, this is a maybe thing. So one of the things, a few years ago, this couch I'm actually sitting on now, I purchased it. I did not measure anything except the space I was going to put the couch into. And so when it arrived, my housemates and the guys delivering it were like, oh yeah, no, that's not going to happen. It won't go. I have an Edwardian flat in San Francisco. So I have this like narrow, windy staircase and narrow doors. And this is a big modern couch. So I didn't measure, and when it arrived, everybody was like, that's not going in. And I'm like, it's going in. I want my couch. It's going in. So with force of will, but also with some creative problem solving, I got it in. And since then, I've had a reputation with my housemates for being able to bend time and space. And they'll usually call me to bend time and space when we need to get something into the refrigerator. So you make this big pot of soup. You want to get it into your refrigerator. And so they open the door and they're like, the refrigerator's full. We can't get it in. Come bend time and space. And I'm like, the refrigerator is not full. There's tons of space in there. It's just really poorly allocated. And in some cases, it's got things in there that shouldn't be in there. So looking at this picture, there's fresh fruit, doesn't need to be in there. An open bowl of soup and an open salad container, that's like recipe for making yourself sick. You should not be storing those things in there. The orange juice can go in the door. The milk should not go in the door. Very bad temperature regulation, not recommended. And then the soup, like that big pot is not like 100% full of soup. It's like a quarter full of soup. So you go ahead and move things around the way they ought to be, put your soup in a container, and there's more room in the fridge when I leave than there was when I started, right? And it's not that I did anything magical. I don't have superpowers. I just was looking at the space and saying, what do we actually need in here, and how do we really want to use this space? And this is something that you can get from the Tidying Up book as well. It's short, it's charming. I really do recommend that people read it. I know there've been a lot of jokes about the whole like, don't keep this unless it sparks joy, but I kind of rewrite that to myself as keep things which are meaningful, right? And in the context of your personal life, that the spark joy thing might make more sense. Is it meaningful to you as a person? But in terms of a business, you want to keep the things that are actually useful to your business, and you don't want to be paying for things you don't need, right? Because you're a business and you want a reasonable costs for everything that you are actually paying for, and certainly storage and processing power are things you're paying quite a bit for. So I think that I picked out a few things, but I really do again recommend the book because I think there are other good ways of thinking about these problems that are in there. But I'm going to go over a few, and they're not specific recommendations, but just ideas about how to think about these kinds of problems. So the first one is, if you have a lot of experience at something, are you actually better at it? So, in her context, it was people who are, professional organizers and go around telling people how to organize their lives. Are they really better at it? Not necessarily, because you can find something that seems to work and you can keep applying that to every problem, but it doesn't actually work. It doesn't keep the problem under control in the longer term. So, you know, I can go around my house and put everything on shelves and in closets and you know, if somebody's coming over, you just sort of sweep everything up and shove it in the closet, right? So that the house looks good. But you haven't really solved the problem, right? And even if you have a more, you know, a more effective method than grab it all and shove it in the closet, um, the reality is that the problem's not under control because clutter keeps coming back. And so unless you have a way of actually addressing the problem in the long term, you know, these quick fix type issues, or these quick fix type ideas, you know, look good on paper, but in real life, they just don't fly. Um, so that's one of the things is that, you know, she talks about, you need to address ongoing maintenance. You can't just like walk in, clean up the room, walk out, and expect that it will then stay that way permanently. Someone's living in it, right? Someone's living in this space. So again, when we're talking about like our personal possessions, you know, we can trim those down a little bit. We can not add a lot more things. You know, don't go out shopping every day and come home with more clutter. But when you're talking about a business, actually, you kind of want the clutter, right? You want rapid data growth. You want to see your chart going like, what do they call it, hockey stick up and to the right, right? So you're going to be constantly accumulating more data, and so you have to look at that as your reality. Your reality is more and more data is coming in, and the more successful you are, the more data is coming in. So you can't just be like, nah, I'm not going to go shopping this week, and I won't put extra, you know, crap in my house. You're going to be like, yes, we want more people to go shopping on our site, and we want to collect more data, and we want to have more orders. So we have to really come up with principles that allow us to actually accommodate that growth. And, you know, going back to what I said we actually did, this sort of horizontal scaling of dividing things into more and more databases. I mean, you can get that down to the point where like each database contains a single table, and then where do you go from there, right? And then you start sharding. So you're just like, okay, now I'm going to slice that table vertically, and then you start, you know, removing data and putting it somewhere else. But it just the problem keeps going. It keeps growing. So is there a solution? I was thinking, you know, is there a way that we can actually manage this growth in a better way without, on the other hand, you know, stopping our business from doing that, because everybody loves that, you know, that up and to the right thing. Or I wonder if is it coming out to the left? I'm seeing myself reversed. Anyway, so another thing is, you know, a lot of times when people look at cleaning up, they look at throwing things out. And one of the principles of the Tidying Up book is that you really shouldn't be thinking about what it is you want to get rid of, but what it is that you want to keep. And another way that this is looked at, I always like the story about, certainly apocryphal, about various sculptors, you know, and they're like, how do you make a statue of an elephant? Well, you get this big block of granite and then you chip away all the parts that aren't an elephant. But it doesn't really work that way, right? Like if I was doing that, I mean, assuming I had any artistic talent, I would probably end up more like a woolly mammoth, right? Because you kind of get to that border between the things you don't want and the things you do want, and it's kind of fuzzy, right? And you're like, I don't know if I should chip this a little bit off or not. I don't know if it's really part or not. And so you get this very fuzzy line between what you can get rid of and what you can't. But if you're looking at it from the other direction, if you're looking at it as what should I keep? What are the things I actually want? Then you can just say, and everything else, you know, sweep that away. So it's just, you know, it's just a different way of looking at the problem. So these ideas are the basis of what came to me. And what I said is, well, you know, we should really look at, you know, in the long run, yes, we need all this data as we're processing, but in the long run, what do we really need, and where and how should we store it, right? If we do need to keep it, how can we keep it in the best way? So I'm going to now go over our order life cycle. Just this is at a very high level. If you've dealt with these sorts of online e-commerce systems, you probably know I've glided over some of the data. But here we go with placing a grocery order online. So the first thing is the customer comes to the website and, you know, they look through our catalog and they pick some items and maybe they apply a coupon or two. They specify replacements when they're checking out. They give us their address and, credit card payment method, pick a delivery time, and now we record this order in our database, right? So now we've got the order from a customer perspective. Now, from our perspective, of course, we want to pay for it. So we do a certain amount of back-end processing where we make sure that we can charge their credit card, and we find a time when there's a shopper available. We figure out how much we're going to offer for that, and then we pass it along to hopefully to a shopper who's willing to do the shopping. So now while the shopper is working on the order, they're going to be making adjustments. I ordered a pound of potatoes, but it's actually a pound and a tenth or a pound and a quarter, because they're odd sized, and they're maybe going to have to replace a few things. They don't have the brand I asked for. Might have to refund a few things because we don't have them at all. In the process, they may have to call into our support team, and so there'll be communications. They might also communicate with me, the customer, and so there's going to be chats and so on. They're scanning the barcodes on the items, so we've got the scans. They take if you've used Instacart these days, they take a photograph when it gets to your door. So there's images going in. There's a map that updates constantly as the driver is getting there, and so there's all sorts of updates happening while it's being fulfilled. So once it's been delivered, we charge for it. So there's some payment processing. This is again behind the scenes. The customer can then come to the website and rate it. They can specify issues. I ordered a bunch of bananas, and what I got was a banana smoothie in the bag, not so much what I wanted. They will again possibly contact our support people and be looking to make changes to get a refund or to add a comment about something there was maybe a bad replacement or something. So again, there's all this data. It's very active at this time, right? All of this time, there are constant updates flowing back and forth between our various applications and our system. But now we have completed the order. And after I did a query to check, and after about a week, no one really touches this anymore. So now it has become a historical order. So once it's done being actively processed, the only time that you would look at it really is to look at the order history, or in the case of like some machine learning, we might want to aggregate some things on, what do we call poor replacements? But what do we really need to keep at this point for the history of the order? Actually, very little of that. So we had I think it was about 30 tables before, but we can really break that down into just 5 or 6 tables. And again, like I say, I'm covering over a lot of detail here. There are really more tables than this, but these are the high level conceptual things. So we need the we need the customer, the store they ordered it from, the items that actually got delivered to the person, and maybe some information about what they ordered versus what they actually got delivered, maybe not. When, the time when it was placed, and how much they paid for it. And that's pretty much it, right? We don't need any of that other stuff. We don't need the communications between the shopper and the customer. We don't need the information about things that that are no longer happening to the order. The transitions between the shopper and so on. So we've cut this data down a lot already, but teasing it apart can be quite difficult. So that's the thing that I think is often difficult in handling these things, is while we can say, okay, all I need is this set of tables, how do I detangle that from all these other tables? They've got references, ID references between them. You're going to have concerns about your data integrity if you just like slice some of it off and leave others in place. So this is back to our woolly mammoth, right? Like we've cut off a bunch of pieces of the stone, but we're still not down to the elephant, right? So the first thing I thought is, well, we're copying all of this data to the data warehouse. So really, we already have a complete copy of the data, and there's a little bit of massaging to get it into the data warehouse, but we don't lose any information. So if we want to do some sort of aggregation over this data, if we want to look into it because, I don't know, there was a manufacturer recall of a product and we wanted to see who ordered it, things like that, we have all that data, and it's in the data warehouse, which is where it belongs, because it is now truly offline data. It's not data that anyone's interacting with. It's just data that we want to occasionally query for various information purposes. What we do not need is to continue to keep all of that data in our live database. So I thought, well, all right, but how do we disentangle that mess? How do we actually remove all the stuff we don't need and keep only the stuff that we do need? And I thought, well, the thing to do is to actually transform it into a single document, because whenever we display a historical order, we display it as a piece. So we're not going back and doing like the history of all the items and what time it was and exactly the weight and how the weight changed from the original weight and what the shopper did and what the shopper said to the customer about it. We don't need any of that. All we're displaying is a list of items that you ordered. So if we transform it into a single record of some sort, and I say document, but it doesn't have to be a document database. It could be anything. That's just how I was thinking about it. Then first of all, it's really fast to access, right? You don't have to join across 30 odd tables and worry about N+1 queries and all of the data. I mean, a table which has maybe a billion rows in it, and you don't want to query that, or data that might have been retired in another table because it's not useful, but your data still references it, which is all that chipping away of old data that we do. So yeah, once it can't be changed any longer, once you know that it's not going to change, take a snapshot of it and put all the data that you actually need to display it as a historical order into a single document. Index it by the customer, the time of the order, maybe the store they ordered from, archive everything else. And if you need to rehydrate it, you can. More likely, you can just look in the data warehouse where all this data is still there. And by cutting it down to just what you need, you use a great deal less storage. The processing power is virtually none to retrieve it. And I'm sure y'all are all familiar with the costs of querying, even with an index. Querying into an indexed table with a billion rows, probably your best performance is log n, and at a billion, that's still significant. If you have 100 rows, sure, you're fine, but when you get to a billion, it starts to get crazy. And it also makes scaling a lot easier, because most of the kinds of data stores that would store this kind of single document are very easy to access and very easy to scale. You just pay Amazon more money and it scales just like servers do, which is just not true for your relational database. So you get a better performance off of your existing live data by getting all this cruft out of the way. Now, there are, of course, nothing's free. There are downsides for sure. The biggest one is putting in place the transformation process, right? So how do you turn 30 tables of data into one document? You do also lose that fine detail. So if somebody comes along, if you every week you transform all your orders, someone comes along the next day and says, oh yeah, I needed that detail from that. Where do you get it? Where do you get your fine detail? You're going to have to retrain your engineers to understand, how to get data out of your document store as well as getting it out of your relational database. And if you're using some sort of system like say Ruby on Rails, as we do, it doesn't naturally write those queries for you. So you're going to have to build something to make that work. And it is very inflexible, right? So let's say that tomorrow, after I've implemented all of this and gotten all this trouble and, built all these documents, someone comes and says, well, yeah, we wanted to also include the shopper information in that order history. And you're like, geez, so I have all these records, which I now have to go back and add this data to all of them. But even so, that actually doesn't happen all that often. Like people design with this idea that, oh, well, in the future, we might want to make that change. So we don't want to make it so difficult to make that change. And then, 5 years down the line, you're still at the company, and they never did anything like that. So why did you, do all that work to maintain all that data that literally no one is ever looking at, right? So is it really worth the trouble to do this? I mean, to me, tidying and again, why I really, the book really made me think about this. Tidying is always worth it. There's a mental weight to having things that you don't need. And in your personal life, that's like, you look around the room and you're just like, God, it's such a mess in here. Or you look at your desk at work and you're like, ah, geez, why do I have all this crap? But in terms of looking at your database, a lot of it is just things like someone will look at it and they're like, what is this even for? Like, what does this mean? And so the cognitive load on everyone, but especially newer people who have to look at stuff and figure out if it's even meaningful anymore because you just never cleaned it up, right? You just kept this stuff that, 7 years ago when the company, was young and small, seemed like a good idea, and we're still collecting that data and no one ever looks at it. Which is another reason why you want to look at what do I want to keep rather than what do I want to get rid of. Because when you look at things like that, historical things, in the context of do I want to get rid of this, and then everyone says, well, I don't even know what that is. And then everyone's like, well, okay, I'm afraid to get rid of it now because I don't know what it is, right? So I did this cost comparison, and this is purely about storage, and I think actually, performance would be more relevant, but this was a very simple picture to do to say, how could you convince somebody that this is a good idea? So let's say that we hope to grow to 1 billion historical orders. I don't believe we are there yet, even with all the growth that we've achieved. I just made that up, but let's say we hope to go to 1 billion, and the average order uses like 200 database rows. Each one of those is a kilobyte of disk space, and we assume that the condensed document that we create is 2K. We're going to store these documents in S3 because it's there and it's cheap, and we're already working with AWS. And we really don't think that people are looking at it that often. And I don't think, I mean, I don't know for sure, but just looking at myself and my grocery orders, when would I even go back to look at it? Like I might look to see, what brand of orange juice did I order last week? That was pretty good. But I'm not going back like 5 years to see, how many potatoes did I order in 2015, right? So ignoring computation costs altogether, and I would actually love to do the computation costs at some point for this. We're looking at paying, and I wrote this talk up about 6 months ago, so I'm going with AWS costs from that time, but I doubt they've changed all that much. So we're paying 23 cents a gigabyte for RDS storage, and we're looking at only about 1/10 as much storage for S3, and it's or only about 1/10 the cost of that for storage in S3. So we've already got an order of magnitude just in the cost of that. But then doing these calculations, we're looking at 200 gigabytes for these 2 billion orders by these numbers that I made up, but only 2 gigabytes in S3. So there's another 2 orders of magnitude. So by the time you're done, you've got 3 orders of magnitude difference in the cost of it, and in real numbers, if we go by these numbers, it would be $552 to pay per year for RDS versus 55 cents a year to pay for the storage in S3. So if you're looking at that kind of cost saving, and that again, you've also got computation costs, but on the other side of it, you've got the costs of, reworking your systems and re-educating your engineers. But still, yeah, I mean, it seems like it's at least worth considering to me. So then why didn't we do it this way? Well, of course, like you're scrambling in the middle of a national or a world emergency to make something work that is being overloaded right now. You can't go and do a thought experiment, right? You have to go with what you know. So I'm still hopeful that at some point we will do something like this. I've put the idea out there, trying to convince people. But certainly when you're scrambling in an emergency, you do what you know. But when you're not scrambling, I think it's really important to think about, is what I know really the right thing, or is it just the thing that I'm really used to doing all the time? Beyond that, I guess thank you for listening. And are there any questions? And yeah.
Great, thank you so much, Muffy. That was really interesting. And let's see, what do we got? Let's see. Looking over at the chat, I don't see any questions. Let's just open it up. Let's see. Any questions? There's other things in chat, but I don't see any questions.
Well, I mentioned
you
there probably
explained
would be, because the last talk I did was very heavily technical and something that we'd actually done. It's always a little harder to ask about a thought experiment, but in lieu of questions, I would be really curious if anyone wants to take some shots at this idea and tell me it's a terrible idea or tell me it's a great idea. Either one.
Paul has his hand raised.
Hi there.
Hey,
Hi there.
Paul.
There's a bit of latency. Hi. There's a bit of latency and unmuting on GoToMeeting on the way on. Interesting. So I guess first of all, this is excellent, and I really appreciated the references to actually reading Mary Kondo, which I haven't done, and getting into the details there, and I've saved screenshots. This is going to be really useful. So my question is about thinking about how we would do this effectively in Postgres, and I have two views of the world. One, the JSONB document-oriented side of things, which seems to be a natural way of doing this. But again, yes, exactly, we cringe at that. At the same time, you have indexing, you have some useful primitives, so it can be done. You can, of course, have a separate a parallel table structure and strip out things and sort of a degenerate table structure, degenerate model with the complexities of transforming things and all of this, and to move different queries and different optimizations, therefore, maybe views if you really want. But then the other option that presents itself with Postgres is the idea of on a large scale now with the newer versions of Postgres, partition tables on a large scale, and coming back to this idea of, well, keep the data the same and simply move the active, make a new active partition every week. If a week is the lifetime, the useful lifetime of the data, then eventually you can stash those other partitions in those old partitions in different table spaces in different storage systems. Who knows what the possibilities are? So with those, and maybe there are other implementation mechanisms that you've thought of, but with those possibilities, how do you, where would you go with this?
Well, I think that the problem with partitioning is this idea of history, right? So you want to be able to present to the user. I've been a customer at Instacart since I've worked there, so 5.5 years. And if the data were partitioned every week and I could only see my last week's orders, it might even look like I don't have any orders at all if I happen to be ordering out a lot, right? So you need to have a representation of the history that is accessible live, even if a lot of it is archived somewhere or semi-archived, as you say, like moved into a less live database. And so that's why I thought of actually transforming it rather than just completely removing the data, because it allows you to maintain a certain amount of history, but it's in a very digested form. And I don't like the idea. I almost did mention JSONB, or even honestly just plain JSON, because you don't even need to query into it, right? You just need to pull the blob out. But if you don't need to query into it, and if you don't really need to join it or relate it to much of anything other than like a user ID, then why keep it in Postgres at all? Because you're basically wearing out your poor database for no reason, because it is not the right place for non-relational data. And I know, it's like anything. I mean, you had, for those of us who are really old, you had Perl, which was a great scripting language, and then they decided to make it web development and object oriented. So they grafted these things onto it. That's not really what it's for. And if the bones of something are not intended for something, you can graph stuff on, but it's not going to support it as well. So I would say, obviously, you could do it in Postgres. I just feel like it's not the best choice. And I also feel like by, moving stuff that isn't important to the, to your relational database out of it, it can perform better.
Just one follow-up point about that with the partitioning. The idea there is that you have a window into all of the partitions with a single table in front of them. I'm describing this poorly. My terminology is
No,
off,
I
but
know what you
you
mean.
can run queries against one table without, and the person who's doing the queries, of course, has to understand some of the performance characteristics and so on, but Postgres will handle that magic of routing your query with old dates to the partition for that date range and so on. What would be required to take advantage of that is probably a composite key that has date, order date, fundamentally in it. Could use sequential IDs also, but an order date would be, and a composite key would make it work. And so those partitions then go on even different. With Amazon, you have 5 or 6 different storage, perhaps not with RDS. You have a smaller number of storage volume types, but nevertheless, you have at least 3 there. If you were using EC2, you'd have 5 or 6 different volume types. So the partitions could be on really different kinds of block stores. They're all EBS, they're all block store, but they have different performance characteristics, different costs, and so on. And all this is transparent up to the point of performance. You have to understand if you're querying, rating some ridiculous query over 3 years worth of orders, no, that's not going to work well. But you have a uniform interface to it. There's one table in front of all these partitions, and the simple management of I'm asking for November 10th, 2020 orders. Postgres will figure out then, oh, this is the partition that Postgres needs to address to return this. So that's more what I was thinking with partitions.
No, I absolutely agree that would work, and indeed we have done that, as you probably know. We have done that with some of our data. I think to me the issue is that we're still joining across, as many as like 30 tables every time. So it's like we're reassembling the same structure every single time, and it's never different. None of the data changes. The query doesn't change. So you're just continually reassembling, it's different users, different orders, sure, but the structure is always the same and the query is always the same. And there's no reason for it to be in this relational form any longer, other than, as you say, a consistency of interface. And that is, it's important, but you also, as you're working with higher and higher level languages and more abstractions, the engineer on the street, if you will, has no idea, perhaps even no idea of whether it's stored in a relational database or not, right? All they know is they call an API endpoint and they say, give me the order, and it comes in as a package, but behind the scenes you have to do all these lookups and joins, but it's going to be the same package every time. So, why are we paying for that? But I agree. I think you're absolutely right that A, it's very doable to partition, and B, maintaining a consistent structure and interface, there's a lot of value to that too. I'm just not sure it's enough value to offset the cost.
This is Richard. I'm a phone caller as opposed to being, with the screen and all that with the camera. If I could interject, please.
Sure.
Great. 2 points. First of all, I think this is a great topic, and more to the discussion that's just happening. One of the great gifts that we can use as architects of our data infrastructure to help us resolve informatics needs in a timely manner is pre-cooking data, technical term, pre-cooking of data that we anticipate might be needed. For example, I happen to be, I was leading a 43-person team at UC Berkeley when the Google guys came through to learn what we knew. And one of the things they saw that we were doing was we had this terabyte-sized database, which at the time was, oh my God, huge. How is it your Earth science database actually responds in real time to these global-sized queries? Well, Of course, we didn't map all the data real time live. We anticipated user queries, and we pre-cooked various resolutions of zoom in our earth science data. And we thought, okay, well, there's different resolutions that would be useful. So to bring that to this situation, I think looking at your anticipated use cases, you can, quote, pre-cook the data for your individual customers and keep something updated for them. When they ask for it, they get a temporarily prompt response, even though it's coming from this other data store. And your online current processing isn't inhibited in any way by this reaching outside the system because it's not involved or potentially not involved at all. So
yeah.
Thank you for letting me
that
address.
boiled my talk down to 5 sentences. Thank you.
Yeah. I do appreciate the topic, by the way, cleaning stuff out. So I've been working on some projects for a while and recently went and said, oh, what's all this clutter about? I need to clear this out. So I appreciated your cleaning out the refrigerator analogy. That was good. Thank you.
Great. Thanks, Richard. Anybody else? Questions, comments, brilliant ideas for working with this? Don't see anybody with their hand up. Okay. Well, gosh. That was great, Muffy. Thank you.
Thank you. I
I
would love if anybody has any further comments, feel free to shoot them at me. It's a problem I'm still trying to solve to a certain degree, so I really appreciate the feedback.
Yes. Oh, and we have comments in the chat. Thank you, Muffy. Great talk from Mike. Thank you, Mike. So yeah, thank you, Muffy, for your time. That was really interesting. And let me just check in. Mark, are there any announcements from Portland that you'd like to share?
Oh, we don't have any. We're still trying to line up some other presentations ourselves, but otherwise, outside of that, we don't have anything going on.
Okay, so like Portland people, Portland's looking for presenters, which segues nicely into San Francisco because we too are looking for presenters. Our next meetup will be Tuesday, May 11. Sorting out details with the speaker. We'll announce that hopefully end of this week, start of next week. But we are always looking for speakers. So if you have a great idea, drop us a note, let us know. We would love to have you all. And again, thank you to Muffy for speaking. Thank you to Mark and the Portland organizers for putting together this joint event. And thank you all for attending, and we'll see you in May.
Thanks.
Thank you.
Thank you, everybody.
Could I add a small announcement for our field?
Thank you.
Oh, sure, sure.
I just want to let people know that on April 28th, coming up in a few weeks, is a class by CJ Date, 50 Years Relational, celebrating the 50th anniversary of the model that we all work with, whether we do so intentionally or not, or whether we did so intentionally or not. But in any case, it looks like a very interesting class. It's $99. There are only 20 slots, even though it's going to be online, of course. But the intent is that it be an interactive kind of event, and you get a 500-page book of some of his database writings to go with it. So if people are interested in that, I encourage you can find it on Google. I just was surprised to see this. This came from the Northern California Oracle user group, and it looks like an interesting opportunity for those of us relational geeks, Richard and others. So.
That's great, Paul. Thank you. I did not know about that. So yay, useful information. Cool. All right. So I think we're all good. So thank you all very much, and we'll do this again in May.
See you guys next time.
Thank you.
Yep.
Bye, and thanks.
Bye.